Hi guys, welcome to today's daily challenge. So day 6, we review about the knowledge of circle in the geometry, and we have 8 questions in total. So the first question, we have a very basic review of the knowledge of radius, the diameter, things. Okay, so CD is the diameter of the circle O, and we have the chord AB is perpendicular to CD at point E. Okay, so this is perpendicular, and then we have the length of CE and AB. So we need to get the length of CD. Okay, so in order to get the length of CD, actually CD is the diameter, right? So if we can get the length of the radius, then we just double it to have the diameter length. And we have a perpendicular, AB perpendicular to CD here. So actually, if we connect OA for the triangle OAE, that would be a right triangle. Okay, and for that right triangle, we can have the EO squared plus EA squared plus equals to OA squared. Okay, and EO equals to R minus the length of CE, which is 2, and EA equals to half of AB, so that would be half of 8, and we have it squared. It equals to OA, which is the radius. Okay, and then we get the radius is 5. So CD equals to 2R, which is D equals to 10. Okay, so this is a very basic question about the diameter and the radius. Okay, and then let's see the second question. It's a proof question. We need to prove that currently we have ABCD 4 points on circle O, and AB equals to CD. We need to prove that AOC equals to DOB. Okay, so how can we prove that? This is a question that helps us to review about the knowledge of arcs, chords, and central angles. Okay, so currently we have AB equals to CD. So both of them are chords in the circle, right? And if we have two chords in a circle are equal, then their intercepted arcs of the same kind and the central angles subtended by them are congruent, which means that we can get the angle AOB equals to the angle COD. And as the angle AOB equals to the angle AOC plus the angle COB, and the angle COD equals to the angle DOB plus the angle COB. So we can get the COB canceled out, so the angle AOC equals to the angle DOB. Okay, so this is a question review about the relationships between arcs, chords, and central angles. Okay, then let's see the third question. We have a circle and we have the angle B equals to 75 degrees. We need to know the angle AOC. So actually this is about the knowledge point inscribed angle theorem. So that would be an inscribed angle is half of a central angle subtended by the same arc. So here we have the arc AC. So the angle B would actually be half of the angle AOC. So the angle AOC equals to 2 times angle B. That would be 150 degrees. So this is about inscribed angle theorem. Okay, and then let's see the fourth question. We have the PA is tangent to the circle O at A, and PB is tangent to the circle O at B. We have OP intersects with O at C. So which of the following is incorrect? Okay, so not correct, but incorrect. So if we have PA and PB tangent to the O, that means we have the OA and OB perpendicular to BP and AP respectively. And we can have the angle 1 equals to the angle 2 and PA equals to PB. And then if we connect AB, we can also know that AB is perpendicular to OP. So therefore AB and C are all correct. So there's no way for us to obtain that AB equals to PA equals to PB. So it's not there's no way to prove that, okay? So D is incorrect, the only incorrect one. The fifth question, we have the circle O is the circumscribed circle of right triangle ABC, and the angle ACB equals to 90 degrees and angle A equals to 25 degrees. So CD is tangent to O at point C, intersecting AB at point D. So what's the angle of D? So let's connect OC. Since we have the CD is tangent to the circle O at C, okay, so we can then know that the angle, so as the circle O is the circumscribed circle of the right triangle ABC, we can have the angle ACB equals to 90 degrees, and therefore the AB is the diameter of the circle O. And if we have the angle A equals to 25 degrees, we can have the angle BOC equals to 2 times the angle A, which is 50 degrees. Okay, so this is also about the inscribe the angle theorem. And then since CD is tangent to the circle O, we have the OC perpendicular to CD. So therefore, we can have the angle D equals to 90 degrees minus the angle BOC, which is 40 degrees. Choice B. Okay, so for question 6, we have the two chords of the circle O, AB, and CD, and then they intersect at P. We know the length of PA, PB, and PC, and then we need to get the length of PD. Okay, so here, let's first connect AD and the CB. And actually, this is a question that's a combination of the similar triangles and the circles. Okay, so currently we know that if two arcs in a circle are congruent, then the chords subtends them are equal and the central angles subtended by them are congruent. Okay, so currently we have the same arc BD, so we know that, so for the angle BAD, actually that's also the angle PAD, okay? So it equals to 1/2 of the angle BOD, and it also equals to the angle PCB. So we have the PAD equals to PCB, and we know that the angle APD equals to the angle BPC. So we can have the triangle APD similar to the triangle CPB by AA, okay? And then we know that we can have PA equals to over PD equals to PC over PB. So we can have PA times PB equals to PD times PC. So that means 2 times 3 equals to PD. So that will be 6 centimeters. Okay. So for question 7, it's also a combination of the knowledge of similar triangles as well as the knowledge of circle. Okay. So if we have the length of PA, AB, and PO, we need to get the radius of the circle O. So first, let us to have the radius of the circle O be x. Okay, let's extend PO to intersect with circle O at point D, and let's connect BD and AC and BC and AD. Okay, so for the same arc AB and AC, we can have the angle ACB equals to the angle ADB. We can also have the angle ADC equals to the angle ABC. Therefore, so we can have the angle PAC equals to the angle ABC plus the angle ACB, which actually equals to the angle ADC plus the angle ADB, which is the angle. So PAC equals to PDB. And also we have the angle APC equals to the angle DPB. Okay, so we can know that the triangle APC is similar to the triangle DPB by AA. Okay, then we can know that we can have the PA over PC equals to PD over PB. And then for PA, it equals to 14, and PC, which is PO minus R, and for PD, it is PO plus R, and we have the length of PB, which is, and we have the length of PB. Okay, so PB is okay, so we can know that 14 times 14 plus 10 equals to 20 minus x and 20 plus x. So we can get x equals to 8, which is choice A. Okay, so this is how we use the knowledge of similar triangles and the knowledge of circle to get the length of radius, okay? And for the last question, it's a combination of, it looks like, okay, and the last question, we can have, we can rearrange the equation of the circle into x minus 2 squared plus y plus 3 squared equals to 13. So this is, we complete the square for x squared minus 4x and y squared plus 6y. And then we can know the center of the circle is 2, negative 3. So this is the center. And therefore, choice D is the correct answer.